Good afternoon. We are presenting for the University of Buffalo Engineers for a Sustainable World team. So this is a list of our team members and mentors. You're lucky enough this semester to have Clayton and Henriette, who were previous UB Solar District Cup team leads. In total, we had 8 people working on the team, some of which only worked on the progress deliverable and some of which only worked on the final deliverable, but overall 8 people contributed. So this was an overall ideal representation of our team structure and workflow. We had meetings 2 times per week in person, each for an hour. So when we started, we used the district use case profile and we immediately got ready with the boundaries. So we had the conceptual team look over those and using Aurora Solar, really getting adjusted to the software and looking for areas with high irradiance. Then we had the financial analysis team working with their Excel, and they were finding variables already in the district use case and putting all those together. And at the same time, the development plan team began basically narrowing down the boundaries. So what we're really looking for is anywhere that was not available for solar panels, either because of other projects coming up or any sort of rules or regulations. So we really wanted to narrow it down and then combine the information from the conceptual design team on where the most light was hitting with the development plan team and really create an idea of where the best panels will be placed. So we all had to work pretty much at the same time to get everything together because obviously there was a little bit of time crunch. That's part of the challenge. So we kind of worked individually. Each meeting, we would share all of our information and then move everything towards the proposed final design. So our district use case, as you've heard 3 times, and you will hear many more, was PNL, owned by the Department of Energy, and their main focus was on resiliency and sustainability. So as we looked more into it, we actually decided to not scrap the sustainability aspect, but we realized that PNL in itself was already using a lot of sustainable energy. If you look through the Richland Energy Services, 92% of their electricity comes from hydroelectric or nuclear energy. So PNL was trying to create a net zero emissions based on the EPA scopes 1 and 2 guidelines, which would actually mean that the energy they were getting was already 72% emissionless based on those same guidelines. So for the most part, we focused pretty much exclusively on resiliency because it was just what PNL needed the most. The main focus of our project was actually looking at PNL's goals, and its innovativeness in itself was to not make an innovative design. We really wanted to create something that worked to support all these amazing groundbreaking technologies and research that PNL is doing. But at the same time, as it's being put in, we wanted something that people had worked with before. We didn't want to be super crazy or edgy and try new techniques because we felt that if there was a problem with the system, we wanted to be able to call in people who had worked on similar systems 100 times before and be able to resolve problems quickly. So that was the main focus throughout this whole design. We came to this conclusion looking at the master and sustainability plans for PNL. So we figured out that their campus goals was mostly to focus on creating open space. It was a huge goal. If you look through a lot of the development plans that PNL has, they focus largely on this. And when it comes to sustainability, they are also big on including nature and natural plants native to the area in their designs. They also wanted to create new learning opportunities, showcase their innovation. Obviously, they're getting taxpayer money to do stuff, so they want to show taxpayers that they do stuff, which would be kind of important, and expanding safety. So the interesting connection between all of this is if you look to the expanding safety section for pedestrians and cyclists, you find out that PNL really wants to decrease traffic. And on the open space, a lot of the reason for creating an open space was to create a better work environment for employees. So they believe that if employees have a better work environment, they do better work. Overall, these PNL goals sound like they're really different or unique in sections, but if you look at the main thing they're striving for, it's efficiency in pretty much every way possible, from how much work their employees do to how traffic flows and how people park in the morning. So a big sustainability goal along with the DOE is to lower greenhouse gas emissions and work towards a net zero campus. So as I said before, with the energy that they're getting from Richland Energy Services, they're already at 92% emissionless energy. So reaching a net zero campus is not very far off for them. And it wasn't really a huge goal for us once we realized this. But still, we wanted to increase renewable energy sources on campus and meet these sustainability goals while decreasing greenhouse gas emissions. But we still wanted to focus largely on resiliency. So one of the first components that we started to look at for this was site investigation. We really wanted to look at an analysis of the legal and infrastructural information for each building and each design, because if it's a federal crime to put something somewhere, you generally don't want to put something in that place. We also looked a lot over the rooftop drawings to determine terrain and then irradiance. That was a huge approach to our initial design, and we felt that it was the best way to start off on a good foot. So we also looked at the utility evaluation. We wanted to analyze the current factors and provide a user-friendly PPA to the customers. And again, customer need. We evaluated the needs of P&L that were both stated and implied, and we really wanted that to be our main motivation for every decision we made. Luckily for us, the P&L main goals were open space, increased or decreased greenhouse gas emissions, and increased visitor tours, which also aligned with a lot of what the community needs anyway. So we got pretty lucky that our community consideration and P&L goals were mostly the same. And I'm going to pass it off to Liam for our proposal.
So here's our proposal, and yep. Here's the top-down view of each of the different portions of our system. Our first one is the ground mount system. It is designed to maximize our power output, and we have around 22K panels, all at 20-degree tilt. Our engineering development laboratory, the north end of the panels has a 15-degree tilt to capture more sunlight and to maximize power. All the other panels are at 5-degree tilt so that they don't overshade over each other and they do not cause power losses in the system. There's about 342 panels on this building. The next one is the Battelle Auditorium. We replicated a similar design for this one. The north end also has 15-degree tilts and 5-degree tilt as well. And there's about 132 panels on this building as well. This is a research building, research operations building. The north end again also has a 15-degree tilt. And there's a little bit of a weird placement because of the trees shading over the panels, and we didn't want to cause power losses in the system. We wanted to maximize efficiency and cost effectiveness. There's about 705 panels on this building. And then there is a pretty similar design for this one as well. As you can see in the bottom right, that's the north end, and those are at 15-degree tilt. And there's 672 panels on this building. And then this one, pretty straightforward and similar design, 658 panels.
Okay, so another main focus of a solar PV system is the impact on the electrical grid. So, why does the impact analysis matter? We want to prevent things such as voltage and thermal overrides, reverse power flow, phase imbalances, and any major fire hazards, because free fireworks shows are fun unless they cause a wildfire in Washington state, which is not fun. But the main reasons that we want to add a PV system are to reduce carbon footprint, create high efficiency performance, stable grid power flow, and create more grid resilience. So how do we achieve both of these? Our design is to implement a smart inverter implementation. So some of the benefits are autonomous decision-making properties, stable voltage regulation, and overriding small distribution caused by a PV system. So this results in solving the circuit with no voltage override by implementing a volt-var curve. And here is our financial analysis. That slide's a mistake. So as you can see here, the cumulative cash flow and tax investor returns for the developer and sponsor, they are increasing their cash flow to almost 40 million overall. And on this slide here as well, they're increasing to almost 2 million over 20 years. So our development plan, for our building and site plan, we wanted to ensure compliance with the building research and park zoning mainly. That had a huge effect on our actual design. And the master plans also were greatly influential to our design, specifically the 2012 and 2017 master plans and the 2017 site sustainability master plan. So we had other projects or other restrictions, such as projects that were in development, Richland Municipal Code, federal land permitting processes, Washington State building codes, and international fire code standards that also affected our design. So as you can see, there are a couple of places inside the bounds that were off limits to us, which is what I was discussing earlier when we said we wanted to essentially decrease our bounds. So as you can see here, it got cut off a little bit, I think, but there are plans for a notional parking and a notional building up in the corner over here, the left-hand corner. And as you can see over here, it's still inside the bounds for this case, but because there's something planned to be there, we decided to remove it, and essentially we cut our bounds and we decreased this. So over here, we also have an example. It's from one of the master plans that shows the hazardous zones. So there was a formal radiochemical processing plant on the PNNL campus. So in general, we tried to avoid instances such as those. So during construction, our main focus is going to be obviously compliance with building codes and regulations, and then risks. So some of the things that we took into consideration were metering each energy source, the solar zones being on non-residential buildings 20 stories or less, while still being greater than 5 feet wide, and the lack of obstructions. The lack of obstructions we typically covered during the site analysis when we looked at Google Earth to determine the rooftop terrain, and we're able to analyze any HVAC systems, pipes, vents, or anything along those lines that would prevent us from putting stuff there. Another huge thing for us was worker safety. We wanted to place panels slightly further apart so that workers could get in between and access them a lot easier during the whole process. So this is the overall timeline for our construction plan. In total, it should take about 10 to 11 months, depending on how fast permitting goes through. So overall, we start with the project definition and planning, so financial analysis, brainstorming, and then the approval and initiation, including the hiring phase, the construction, which includes the installation of solar panels and interconnection, and finally, the project closure. So our innovation and results. In total, our system produces 11 gigawatt hours of output. So for reference, we got some Excel files that show that for buildings 3860, 3400, and 3820, the total output is 1.1 gigawatt hours per year. So for reference, we're making about 10 times that for the 3 buildings. So we are still helping to meet the net zero emissions goal, and we're limiting change to aesthetics while preserving the open space that PNNL really wanted by using the rooftop designs mostly. And we have several opportunities for improved community engagement. So some of our ideas were basically to increase public interest in solar energy. That was most of the reason for putting in the ground mount system as well. When we have a rooftop system, people can't really see it. So when visitors come and PNNL is trying to show that they use sustainable energy and renewable energy sources, it's a little bit difficult for them to see the rooftop system and really visualize what that means. So we thought that by putting in a ground mount system, they would give a new place on the tour to show innovations. And then as PNNL is working with other sorts of renewable energy, they can show and compare them to the system in place. Obviously, it's taking up a lot of space. So they might say something such as our laboratory technicians are working on something that would produce this much energy, but take up a significantly smaller amount of space, and then allow people to visualize some of the effects of their work. There was also a possibility for solar charging stations for phones and bikes. As I said before, PNNL was also working on decreasing traffic flow by allowing more safety for pedestrians and cyclists. So by increasing solar charging stations for bikes, we could encourage more people to cycle and in turn decrease traffic flow for cars. So that is the end of our presentation. Thank you for listening to us, and let us know if you have any questions.